Hey, welcome back, and in this video I'm going to show you how you can speed up your Docker builds for your Rust applications using a really cool tool called Cargo Chef. But rather than just showing you how Cargo Chef work, I thought it would be more interesting to actually spend a little bit of time showing you how multi-stage Docker builds work and then how you can shrink down your overall image size by using builder images and then using Google distroless as your run image. And then of course you will see the frustration that you have with the build time, and then I can show you how Cargo Chef is going to speed that up. And the reason I'm doing this video is actually I was building another video on how to run your Rust applications on Google Cloud Run, which is Google serverless container offering. So again, that will come soon in another video, but for now let's get started and let's have a lot of fun. Alright, to get started, what we're going to do is spin ourselves up a very quick web server. We're going to use actix-web, which is a super fast web server written in Rust, and we'll just create that really quickly with a very simple hello world, and then we'll use that as our basis to create our multi-stage Dockerfile, and then we'll obviously look at the problems and then speed up the build. So to do that, I am going to just create a brand new Rust project. So to do that, I'm just going to type in cargo new actix-web hello, and I'll just give it a number, let's say hello 1. And that is going to scaffold up my new application called actix-web hello 1. If you're not familiar with Rust and you want to understand how things like cargo new and cargo build and all that sort of things work, then I do have another video which gives you a getting started guide to Rust, so feel free to check that out, and that will tell you how to get Rust installed and get started with it quickly. But in all honesty, this video is pretty simple, so you should be able to follow on quite quickly. Okay, so now that we've created that, we'll just cd into that folder. So we'll cd into hello 1, and then as you can see, it's created a cargo toml file and it's got a source directory. So what I'm going to do is I'm going to spin up Visual Studio Code, and then we're going to look at what's being created within that environment. So to do that, I just type in code dot. And what that'll do is launch Visual Studio Code in the folder that I was in. And as you can see, we've got this source file. You've got your main.rs, which prints this sort of hello world. You've got this target folder, which has got all of the build out artifacts that get created when you run a Rust application. And then you've got the get.ignore file, which ignores the target file, and then this cargo log and cargo toml file. Okay, so if I wanted to make sure this application works, all I need to do is go back to my terminal and type in cargo run, and then it will come back with hello world. So we'll do that very quickly. We'll just bring up our terminal. We'll type in cargo run, and then you can see it will build the application. It'll take a few seconds to do that, and as you can see, it came back with hello world. So we've got a working application, but now what I want to do is replace that application with a working web server. So as I said, what I'm going to do is we're going to use a web server called actix-web. So you can actually just go to the website, which is actix.rs, as you can see, and I'll expand that out. And as you say, a powerful, pragmatic, and extremely fast web framework for Rust. So actually, it's super fast. On my machine, it runs at something like 260,000 requests per second. It is one of the fastest web servers in the world, and it's been sort of ranked as that in the Tech and Power rankings. So again, it's a really great web server. Feel free to check that out. And actually, if you want to see a comparison between actix-web and Rocket, then I have another video where I do a sort of web performance test between the two frameworks and talk about some of the differences. And if you want to check that out, there'll be something appearing in the top corner there, and you can click on that and watch that video. So all we are going to do, as you can see, the nice thing about Actix is it's actually got a nice example there, straight up in the front page. So we will actually, let's be super lazy about this. Let's just copy and paste that into our Rust application, and we'll use that as our starting point. So we'll just get rid of our main function that we had before, and then we'll just paste in the code that we copied and pasted from that website. So if we do that and then we hit save, you can see there's a bunch of red squigglies coming up, and basically it's because we haven't imported the dependency for actix-web just now. So if I just come back into my cargo toml for a second, you can see there's a dependencies piece here. So all I'm going to do is I'm going to put in actix-web here, and then we will set the version. And I think The version at the moment is 4.01, but if I just save that, you can see there's a green tick, and then it gives you a bunch of options that you have there, but you can see 4.01 is the latest version. So we'll just save that, and then if we come back into the main.rs, we can see that all the squigglies over the actix-web, get-web, and all that is disappeared because we've now added that dependency. There is a squiggly on the hello name, and it's saying there's no argument name. So we'll just get rid of that here, and we'll put name here, and that should fix that. So just to sort of go through what this code is actually doing, and then I'll show you how that works. You see it's creating an HTTP server there, and then what it's got here is you can see the sort of path / there. And then you can see there's an async hello world. So what's actually happening in this case is that if you hit 127.0.0.1 on 8080, on the root of that is going to return a hello world. And then you can see this service binding here as well, where it's going to call this greet person function. So therefore, if I put a / Chris or Fred or Jemima, then it's going to come back with hello, whatever name I passed in there. So we can check that works. So all we need to do is go back to our terminal. And what I'm going to do here is I'm just going to do a cargo run for a second, and then that should build and compile that web server, and then we'll do a run. So as you say, cargo run has happened. It takes a little bit of time to go and get all of those repos down and build that and then run it. But as you can see, it's up and running now. So if I then just open up a new tab here, we'll just clear this. And if I was to do a curl localhost 8080, then what I would expect is it came back with that hello world that we saw a second ago. But again, if I were to put a / on that and then I put in Fred, I'm going to expect that to say hello Fred, which it does. And then I can put anything in there as well. So if I put Chris, it comes back with hello Chris. So we now have a working web server with actix-web. So the next thing that we need to do is, at the moment this is running natively on my local machine, and what I want to be able to do is move that so that it runs within a Docker image. Okay, to do that, what we're going to do is we're going to go back into Visual Studio Code, and let's just close all this down for a second. And what I'm going to do now is I am going to add in a brand new Docker file. So I'll just click on New File in Visual Studio Code, and we'll call that file dockerfile. Let's just close our cargo toml file. And what we're going to do is we're not going to do anything like multi-stage builds just now. What we're going to do is just use one of the out-of-the-box Rust images to start with and get our application working. And then we're going to start seeing the issues, and we're going to start optimizing them as we go along. So in this case, I am going to use the out-of-the-box Rust image, which comes from Docker Hub. So it's the official Rust image. It's got all the Rust tools as part of that. So we will just run with that straight away. And then the first thing I need to do is I need to essentially copy my files into a little app folder. So and at the moment, I just want to copy everything in there. We won't want to copy that target folder, but we'll go through that in a second. So to copy the app into that image, all I need to do is use the copy command. So we'll just say copy the app into the Docker image. And I might as well put a comment on the first one as well, because I like to have nice little comments. Use the main official Rust Docker image. Okay. So we're going to do that copy, and in Docker the copy command, surprisingly enough, is copy. So we're going to copy the contents, so it's expecting it in source to destination, so we're going to copy the contents of our source folder, which in this case is going to be dot, and we're going to put this into a brand new folder which we're going to call app. And then the last thing I want to do is set the working directory to the app folder. So we'll just say work there, and we'll set that to app. And what that basically means is that just it's like a kind of CD. So just CD into that app directory. That's your starting point. That's your starting folder. Okay. So once we've done that, what we want to be able to do is run and build the application. So I'm going to be super lazy in this case. I'm just going to do a build. So we'll do build the app. and we'll do the run command, and we'll do a cargo build -- release. So what we're saying in this case is when I do a cargo run before, what that's actually doing is a two-step process. It's doing a build and then it's doing a run. And what we're trying to do here is we're separating the process out, which is I want to build the application first. Once that's built, and then later on I'm going to do the run, and I'll show you what that in a second is. What the -- release that you're saying there is, what I'm saying is do all the optimizations, create me a release build, don't create me a debug build. So all of the debug symbols and all that won't be shipped as part of this. So what I'm saying is I'm doing this release build. So when I did a cargo run that you saw earlier, what it was doing there is doing a debug build. Now I'm doing a release build. Now that that's running, the last thing I want to do is start my application. So we'll just say start the application. So whenever I start my Docker image, then what I want to do is run that command. So in that case, we will use the cmd command, and we are going to pass in the name of the file. So in this case, we created something called actix-web hello1, so that will be the name. So whenever that Docker image starts, it is gonna go to that exe that we just created, and then it's going to run that. And you can actually kind of see that. So if I go into that target folder, and you can kind of see there's in the debug folder, if we did a -- release when we ran this earlier, it would have a folder called release, and then you can see underneath there is actix-web hello1. So that is basically what we are going to be running. And the last thing I want to do before I go and build that image is I actually need to create myself a dockerIgnore file. So we'll just do that. A dockerIgnore is very similar to a gitignore, so we'll just create one. It's called .dockerIgnore. And then what we want to do is specify all the folders of files that we don't want to be included in the build. So in this case, I don't want that target folder to be copied into the Docker image, so I'm going to add that in. But I don't want the Docker file, or I don't actually even want the dockerIgnore file. I don't want anything in the Git folders, and I don't want my gitignore either. So that is a nice sort of base dockerIgnore, so none of those files would get copied into my Docker image when I do my Docker build. Okay, so now that I've done that, what I'm going to do is we'll go back to the terminal and we will do a Docker build and see what that looks like. Okay, so let's clear that for a second. And in my terminal, if I were to type in Docker images, you can see I've got no Docker images at the moment in my registry, so it's completely clear. And by the way, as a sort of prerequisite in this case, I'm using Docker Desktop, so I would recommend that you do the same, and that will help you sort of follow along. I'm going to stop the server that we had there earlier as well. And now to build this, what I'm going to do is type in docker build, and I'm going to do -t, so I'm going to give it a tag. So I'm going to call it Chris Hey UK actix-web hello 1. So what it's going to do is it's going to do that build, and it's going to give it the name Chris Hey UK /actix-web hello 1. And then I'm just going to put a dot in here. So what I'm saying to it is part of the build process, use the Docker file that we just created, which is in that source directory. So if I now hit return, it's going to go and build that. And as you will see from this is going to take a long time to build. So we downloaded the Rust file fairly quickly, so it's pulled that from there, and I think it's got cache from me building this before. But as you can see, this run cargo build release stage is taking ages. And what I'm going to do is we'll wait until this is finished, and then I'll speed it up a little bit, and then we can you'll get an idea of how long it takes to do this Docker build. So far we're about 85 seconds into the build, and if you just look here, it's still going, and you can see what's actually happening is in order to do that build for actix-web, it has got to download all of the dependencies and the packages that are used as part of actix-web, and then it's got to individually compile this. So we're now sort of 104 seconds in, and it's still compiling. So this is a super slow process. And then finally, after 128 seconds, we have completed our build, and we now have a Docker image. So if I was to type in Docker images, you can see we've got a new image called actix-web hello 1 in the Chris Hay UK organization. Its tag is latest and it was created 15 seconds ago. But what I want you to see is the size of this is absolutely massive. It's a 2.1 gig image. So we'll just check the image runs okay, so I'll run that in a second. But there's 2 pain points that I want you to realize so far in this process. Number 1, it is a super slow build. It's taking me over 2 minutes at the moment to build that image. But the second one is I've got this huge size of a file. So the 2 things that I want to do is speed up that build process, and then the second one I want to be able to do is reduce that Docker image size. Okay, so what we're going to do now is we're going to start up a Docker image. So if I just type in docker run, which basically says, you know, run the image that I'm about to give you, I want this to run on port 8080. If you remember in our image, we exposed our actix-web server on port 8080. That's what we asked it to start up on. So what we need to do is expose that port from within the image to the outside world so that we can call that. So to do that, we just pass in 8080. And then what I want it to do is run the image called Chris Hay UK actix-web hello. And if you remember, when we opened up our Docker images, I tagged this as Chris Hay UK actix-web hello 1. So that is the image we want it to run. So if we run that, what you're actually going to find, and I'm being a little bit of a cheat here, you're going to find that it's not going to run. And the reason it's not going to run is I set the command to the wrong file, right, the wrong location, and then what we're going to do is go back and modify that. So if I hit that and hit run, you can see it comes back with an error. And if we look at that error, as you can see, it says container line, starting container process, blah blah blah, no such file or directory unknown. So it can't find that, and the reason it can't find it is it's not in that folder, it's in that target release folder. So what we're going to do is go back into Visual Studio Code, and then we'll make a change, and then you're going to start to see a little bit of the advantages of Docker at that point. So we'll just open up Visual Studio Code, and as I said before, it's in the target release folder. So we've got target debug here, but when we do the build within Docker, it's obviously going to create that release folder as part of that build process. So remember, if you think about that build process for a second, that target folder doesn't get copied across, but when we build our Docker image, it's going to do that build like we did on my machine, and it's going to create that release folder, and there's going to be something called actix-web on there. So what we will do is we will just put in here target release, and we'll just save that. And what you'll find now is when we do the Docker build, it's going to start treating each one of these as a layer. So every statement that you've got acts as a layer within Docker. So it's going to look at this and say, actually, I've got this already. Actually, I've got all this already. Actually, I've got all this already. And then it's going to skip past that because it's going to say there's no changes there. So we're going to get to a sort of super quick change, which is just the CMD file. So I'm just going to save that. And then if we now run our Docker build again, so what will happen there is, as you see very, very quickly, it sort of skipped past all of those files, you know, copy work directory, and it's essentially just using these cached layers that it's created. So what now that we've changing just the very last statement, which is that command file, because there hasn't been any changes to the files, hasn't been any changes to the underlying Rust base image, etc., then it can just use the cached image. So cached. So it doesn't even run the car build release again because none of the files have changed in that folder, so it doesn't need to run it again, and it goes straight to just changing that command file. So now, let's just clear that. If I was to just run the Docker run again, you're now going to see that it runs. So that is one of the advantages of Docker as part of its sort of build system. So before I run that, if I just do a Docker images again on this machine, you can see there's my actix-web hello 1 image that I created at 2.1 gig in size, huge. If I do a Docker PS, you can see that Chris Hay UK actix-web hello 1 is running, so that's cool as well. And now if I was to do a curl localhost 8080, and you can see it's coming back with an empty reply from server. Why is it coming back with an empty reply from server? Well, actually, this is again back to the way that Docker works. So if I come back into my Visual Studio Code for a second, and we come back to the main.rs, what I want you to see is that it's bound to the 127.0.0.1. When I'm working with Docker, I need to bind to any underlying IP address. So in this case, it needs to be 0.0.0 to make that work. So if I just save that, and what we're going to have to do is do another build. So rather than binding to 127.0.0.1, it's going to be bound to 0.0.0, which is any IP address, on port 80, and that will work. So if I just kill that for a second, we'll clear this, just make sure it works on our local machine before we do a Docker build. So if I do a cargo run, it's going to do that build and it's up and running. And again, it was super fast there, so which is great. And then if I do a curl localhost 8080, you see it's back and up and running natively. So what I can now do is do my Docker build. So I'm just going to do a Docker build, and you're going to start to see the problems with Docker at this stage and slow compilation. So if I do that Docker build, the good news is that, as you can see there, it's taken the cache, so it's taken that Rust image here that we've got super fast. Yeah, so that's good. We're in a nice position there. But even though I've made that one change, it's now having to go and rebuild, download all of those crates again. And it's going to take a huge amount of time to do that. So, even though all of those dependencies we haven't changed at all I've done is change the binding IP address there, it's still going to have to bring down all of those dependencies, compile them, and then finally you make that last change. And this is the problem with Rust when you're doing a build. So it's still going to take around 120 seconds. So that is what we are going to look to fix up using Cargo Chef, and we'll get to that in a second. So we'll let this speed on a bit, and then once that's built, we'll show it works, and then we'll start to optimize this. So as you see now, it's actually starting to do all of those downloads and compiling, just as I said. So this is why that workflow becomes super slow. Okay, so our image is built, and if I do a Docker images, you will be able to see that, there we go, Chris A UK, actix-web hello 1, created 8 seconds ago, size 2.1 gig. But as you can see there, it took 127 seconds. So this is a really slow workflow. So anytime I make a code change, if I want to build a new Docker image, as it stands at the moment, it's going to take over 2 minutes. And I've got this huge image. And the reason I've got a huge image is because all of the Rust tools that you need for building, such as cargo, etc., is all in that image, and that's why it contributes to that size. So to solve both of these problems, good news is we're going to use essentially the same techniques. And the first thing that we need to do is introduce this concept of multi-stage builds. And by introducing multi-stage builds, what we will be able to do is then start using those caching layers to our advantage, so that we can then build with the large Rust image, but then we can deploy onto a much smaller image that is suitable for production run, and that wouldn't have any of those compilation tools, etc. And that will allow us to run with much smaller images, and then we'll extend that further to be able to speed up the build time. Okay, so let's clear that for just now. Just before we go and do a multi-stage build, let's just make sure a Docker image now works. So if we just do a Docker run on 8080 and start up Chris A UK actix-web hello 1, and what you should now see is that our Docker image is up and running. So if I now do a curl localhost 8080, you can see it's come back with hello world, and I can do something like Fred and it will say hello Fred. So that is our application now running and working, and we're executing against it, but it's running within that Docker image. So we're in a good position just now, so let's close that down. So we've stopped the Docker image, and what we're going to do is look at improving that with multi-stage builds. Okay, so let's go back into Visual Studio Code. We're going to close all of this down for a second, and we're going to come back to this Docker file. So as I said before, what we want to do is split our Docker file into 2 stages. The first stage is the build stage, and then the second stage is going to be essentially our running image. So we're going to use one image to build and then a different image to run. So obviously I want to use that Rust image as my build image because it's got all the build tools that I need. So what I'm going to do is I'm going to call this as our builder image. So we'll as our builder. So we've now got an image called Rust and it's called our builder image. So the steps that I've got in here are the same at the moment. So I'm still going to do that copy of the app. I'm still going to set the work directory. So that's all going to be fine. And I'm still going to build my app as I did before. So I'm not making any changes to there. But as I said, I don't want to run that command, the actix-web hello1, from in my builder image. I want to have a new image that I'm going to use for runtime. So this is the point of separation. So I am going to create a new image at this point, and it's going to be my running image. So to do that, I'm going to use a very small image, which is provided by Google, and that is a distroless image. So it's very, very small. It's got minimal tools as part of that, and it should give me a sort of an image size of around 38 meg. So that's what I'm going to use as my run image. So we'll just say use Google distroless as runtime image. Oh, I made a little error there. Not that it matters. So to do that, we'll just put from. And that image is in GCR.io, so that's the container registry. And that is actually within distroless, so we'll just type that in. And then the name of the image is CC Debian, and it's version 11 that we're going to use. And if you want, you can actually just bring up that image directly within Google Console. So if I just paste that in there, I obviously have a Google account already, but you can kind of see there is GCR.io. It's a public image. It's within this distroless folder, and you can see CC Debian 11, which is what we're going to use. So actually, if you look at that within the distroless folder, you can see they've got a whole bunch of other distroless images. So you can see Debian 10, 9, etc. You can see Java images. You can see Node.js images as well. So what they've done in those cases included Node.js or Java as well as the operating system, or in this case Python. So there's lots of different options and versions there. But as I said, we're going to use the Debian 11 image. So let's just close that down for a second. Okay, so let's get back to our Dockerfile for a second. And as we can see, we've now got our runtime image. So we're obviously going to run from this distroless Debian 11 image, which doesn't have any of the build tools, which is going to be much smaller. But obviously we don't have our application, right? We've got the command file there, which is great, and it's going to start actix-web hello1. But as it stands, we don't have actix-web hello1 within that image. It's an empty image. It's only got the base operating tools. So what we really want to be able to do is copy the application that we built in this builder image into this runtime image that we're going to use. So to do that, we're going to use that copy command again. So we're going to write copy app from builder. So to do that, we'll just write copy as we did before. And this is where we use the -- from command. And what that allows you to do, as I said, it's a multi-stage build, and allows you to copy a file from one of the other stages. So in this case, we want to copy it from the builder stage. So once we've got that, we can then decide what file we want. So it's obviously given us a source and a destination. So if you remember, our file was living in the app target folder, and we called actix-web hello1. So as you can see, that was the file there, target release actix-web hello1. And what we want to be able to do is copy this into our app folder that is on this machine. And in that case, we will just call it the exact same name, which is actix-web hello1. And of course, we might as well set our work there to now be an app. And that's goodness. And then finally, all we need to do now is just get rid of that target release and start actix-web hello1. So if I save that, we now have our multi-stage build file. So as I said, we've got this builder image at the top here, or this builder stage, and then we've got our runtime image. So we will build our actix-web hello1 in the builder image, and then we're going to use this distroless Debian 11 image, and then what we will do, which is much smaller and doesn't contain any of the rustls, and then what we'll do is copy the app that we built over here into this app folder that we've created, and then we'll just execute the file. So if we just save that and we come back to our terminal, and what we're going to do is we're going to run a Docker build exactly like we did before. So Docker build -t Chris Hey UK actix-web hello 1. We'll just run that, and then it's going to go and execute all of that. Oh, and we've got an error there. It looks like I missed the word release, which I did. We've got app target, but of course there's a release folder. So I'll just add in release here. So it's app target release actix-web hello 1 to the app folder. So if we just come back to here again, do our Docker build again. And again, that was a super fast build there, right? It's done that super quick. It's used a lot of caching there. It's pulled the Debian 11 image, etc. On your machine, it's going to take a little bit slower because it's obviously going to have to pull that distroless image down. So it'll take a little bit slower the first time, but then after that's built and running, it'll be super, super quick. But as you see, we've got a multi-stage build now. So if I was just to clear this and do a Docker images, you are going to see that the size of our Docker file is much, much smaller. Okay, so we'll just hit return. And as you can see, that actix-web hello 1 Docker image that we just created 47 seconds ago was 27 meg in size. Now compare that to the 2.1 gig image size that we had early. Massive difference, right? So that's just something to be aware of. That is the big advantage of multi-stage builds, that it's just going to save you so much time and size, right? Because you don't have this massive file with all the rustls, things that you don't need. So you can do all the building, as I said before, on an image that's 2.1 gig, but when you want to deploy that to a production environment on something like Google Cloud Run or something, then that image you can deploy is going to be super tiny at 27.9 megabytes. So that is huge. So good news is we've solved one of the problems. Before we do that, let's just run it, make sure it works okay. So we'll do a Docker run just like we did before. It's now running, and then if we run a curl localhost there, it's coming back with hello Fred, and then I can do Freddy, hello Freddy. So the application is still working, but obviously the image size is much, much smaller. Okay, so we've solved one of the problems, which is the super large image sizes, but we haven't solved the other problem, which is our build times are still going to be mega slow. So if I come back into Visual Studio Code, and let's say I try and change something in this file. So let's say rather than going hello, it goes hello, with a couple of those there. And then if I try and do that Docker build again, we're going to be back into this scenario that it's going to absolutely take ages. So even though we're getting the advantage of the caching, so you can see that first from Docker is pulling from the cached images there. But as soon as I hit that cargo build release, even though I've changed something that doesn't affect any of the dependencies, it's still going to get back to taking sort of 120 seconds. So my workflow here is super, super slow. So what I want to be able to do is speed that up and try and make use of this caching mechanism that Docker's got built into that. And probably the easiest way of thinking about this, if we come back to the multi-stage, is we've had a stage where we've built our application, which is super cool. On that builder image, and then we've got a second stage where we build the production image and we copy the files across. So the logical thing that we want to be able to do maybe is, since we're not making any changes to the dependencies, could we separate out the building of the dependencies from the building of the application? And the reason that we would want to do that is that if you remember from the build process, which is currently running on my machine at the moment, the bit that's taking the huge amount of time is the downloading of those dependencies and the compiling of those dependencies. But that is the bit that's quite static, right? So if we can cache that, that means that we are going to be in a position that when we want to just change our application, maybe I'm just changing that from hello to hello, then that would mean that it doesn't need to compile and download all of those dependencies. It can just use the cache version of that image, and then we're on the super fast part. So that's what we want to do. And the way that we can do that is by using that multi-stage file again, and what we can do is introduce a layer for building dependencies, another stage like we've done before. And actually, if that technique sounds familiar, anybody who's coded in something like Node.js, that's exactly what we do with our CI builds in Node.js. In fact, I've got another video on that, so if you click on the top right hand corner, you will see a multi-stage image building for Node.js images, and it's exactly the same technique as we use there to build dependencies that we can use for Rust. So let's get onto that and do that right now. We could do it manually. So what we could do is just create an empty main.rust file and then do a sort of print line statement, you know, just saying hello world or whatever, but then copying the same cargo toml files in, and then that means that we can build all the dependencies from that empty application. But that's super hacky, right? And that's why there is got to be a better way, and that better way is a tool called Cargo Chef. And what Cargo Chef does is production all of that and allow you to build those dependencies independently of your application. So what we're going to do here is the first thing that we need to do is then start separating out the building of the dependencies from the building of our application, and we'll do that with another stage. So that first stage in Cargo Chef is they need to do an analysis of your source code and then essentially generate out a JSON file, and they call it a recipe file, but it's essentially a JSON file which lists all of the dependencies for your application. So let's do that. So the first thing what we need to do is create a new stage. So we'll put a comment. So stage 1, generate a recipe file for dependencies. So we will use our Rust image like we did before, and in this case we'll call it a planner. So that is going to be the stage, or planning stage, right? And we obviously need a work there again, so we'll say we'll have an app as our work directory one more time, and then I need to install the Cargo Chef tool, right? So I will just do a run cargo install Cargo Chef. And again, if you want to know more about Cargo Chef, feel free to Google it and have a look at the package, and there's really good documentation on, so have a look. So in this case, where we are at the moment, we've got an empty Rust image, we've got a blank directory called app, and now what we've done is we've installed the Cargo Chef tools within that. So in order to analyze our application, we need to copy all our source code into the app directory. So it's a copy ... which will just copy all of our source files into the app directory. And then what we can now do is use Cargo Chef to generate that recipe file that we're going to use to build our dependencies later. So how Cargo Chef does that is you just type in run cargo chef, and that stage is called a prepare stage. So we're creating a recipe JSON file. So we'll just type prepare, and as I said, we want it to create a recipe JSON file. So we just pass in the path of the file, so --recipe.path. And that is going to be recipe.json. So what that will now do is create a recipe JSON file, which is going to have all the dependencies and everything that it needs to download. So it's analyzed our application. So the next thing that we need to do, which is stage 2, is we need to build our dependencies. And by the way, if this is feeling super familiar, then this is exactly what you do with Node.js. I've said that before, I'll say it again, right? Which is, if you look at building Node.js applications using something like npm CI, this is exactly the same techniques as we use in Node.js, which is we separate out dependencies, we build our dependencies, and then what we'll do is copy our dependencies into our application. So let's build those dependencies. So I need another stage. So I'm just going to use the Rust image again. In this case, I'm going to call this our caching stage, or cacher. I'm going to have another work there as app, so that's cool. And then it's a blank image again. So what I'm going to have to do is I'm going to have to install Cargo Chef one more time. So I will just, exactly as I did before, in fact, I could just copy and paste that. So now I'm going to have an image called or empty Rust image, but now I've got cargo chef installed one more time. But what I now need to do in order to build the dependencies, I need to copy that recipe JSON file that I created in my planner stage, and I need to put that into this cacher stage that I've created. So just like we did before when we were building a production image, I will use a copy, and I'll use the -- from, and then it offers me up the stages. So I want to copy from the planner stage, and I want to copy the app recipe JSON file, and I want to place that in my app folder that I've got just now, and I want to call that recipe JSON. So now where we are is I've got my Rust image, I've got cargo chef installed, and I've copied in my recipe JSON file from the planner stage. So what I obviously need to do is I need to then do the build and get those dependencies. How that works is I do a run, and then chef has this tool, cargo chef has this tool, which is called cook. And what that means is it's all very cookie and recipe like, right? But what that's going to do is generate all our dependencies, build them, download them, based off of that recipe JSON file that we created in the previous stage. So I'll just type in run cargo chef, and in this case I'm going to do a cook, and I'm going to pass in -- release because I want it to be a release build. So I want my dependencies built as a release, none of the debug files and all that sort of stuff. And then I want it to use the recipe path that we just copied in, which is called recipe.json. So now I have built my dependencies. So stage 3 is going to be use create a builder image. So none of that changes from before. I still have my Rust image as a builder. I copy my app. I have my work directory as an app. But now what I need to do in here is, before I do that build, remember that is the slow part of this application, is doing the cargo build release. What I need to do is copy all of the dependencies that I've built in the cacher stage, and I want to copy that into my application folder, my app folder, so that it doesn't download and build them again, right? So if I don't do anything here, it's just going to do the exact same thing. So to do that, I just need to say copy dependencies, and I'm going to do another copy, and in this case I'm going to copy from the cacher stage. So copy from cacher, and what I'm going to do there is I'm going to copy in the target folder. Remember over here, the target folder is where I build. So what I want to do is copy the target release folder into here, but actually I can just copy the entire target folder. So I'm just going to copy app target, and I want to give that the name target like before. So what will happen there is the target folder that we built in our caching stage is going to be copied from that cacher stage here, and we're going to pull that whole target folder into this image here, the builder image, and that's going to be present, and therefore all the dependencies will be pre-built, so that when we do that cargo build release, it's not going to feel the need to download that again, it's not going to feel the need to compile that again, it's just going to be present in that folder, and therefore it can build my application. So now that I've copied that target folder, the last thing that I want to copy in here is I want to copy my cargo folder from my previous image, from my dependency image, or my cacher image into my builder image, and again that's going to help speed things up as well, right? So it's going to help get that super fast because it's going to have all of those kind of previous dependency history that we've got. So if I just hit save, so now that we made all of those changes, what we're going to do now is just start changing our application and see how fast it runs. So I've got hello here, and what we're going to go type in is wee, and then if I just do a docker build, and we'll just run that for a second, and as you can see, it is just running at lightning speed. So the whole builder image process is using those Docker caching layers, but it's now run that in 6 seconds. And again, I can make any changes that I want here. So I can say, rather than we, I can go hey, and then run that Docker build again, and it's going to take another 6 seconds or so. As you can see, it's completed in 7.3 seconds. So that multi-stage build that we've got, remember it was taking over 2 minutes, but just by following those stages where we generate the recipe file, we build our dependencies, we're using Docker caching and multi-stage images to our advantage, is really speeding up this image. And I think the two key things that you remember to build in this image is you're going to pull that target directory across there, and you're going to pull our cargo directory across there from our cache layer, and now our images are running in 7 seconds. So rather than taking 2 minutes to run a build of a Docker image, we can go back and we can make any changes that we want. Whoosh, just hit save and then do a build, and then 6-7 seconds later our application is built and it's running at super speed. So this is kind of like a 10x improvement on that machine. And then of course, if I just want to run my image to kind of prove that everything was working as it was before, I can just use the docker run command. So if I just do a docker run, our application is running, and then I'll just do a curl localhost there, and it says whoosh Freddy, so you can see it's running. So we have solved basically the two things that I said we were going to solve, which was I brought the image down to 27 megabytes using multi-stage from the 2.1 gig that it was before. And the other thing that we've solved there is that we've taken the build time from over 2 minutes down to 6 seconds to build the application. So that's really what we wanted. Now I guess if I was going to finish this off, last thing I want to do is just get ourselves into a nice state from a security perspective, because I've done a multi-stage build there, but as you kind of seen there, everything that I've run on my machine was running as root, because that is the default for Docker. So let's just create ourselves a new user for our final production image, which is going to be a least privileged user. Okay, so to create a least privileged user in my multi-stage build, what I'm going to do is I'm going to go back into my builder image for a second. I need to create my user within the builder image, because that's where all the tools are going to be. So within Rust Builder, what I'm going to do here is just create a user, so called web, with a user ID of 1001. And to do that, I'm going to run the add user tool, which is going to be part of the Rust Builder image. I'm going to disable passwords. I'm going to switch off all the shell stuff is there, but you can see it's going to create it with that user ID that I've specified with that username. So that's goodness. That's going to be created within the builder image. And then what I need to do is copy those usernames and passwords that I've created on the builder image into my production image. So to do that, I just basically need to use the same technique as I did before for copying the application across. I'm just going to do a copy from builder, and I'm going to copy across the password file, and I'm going to copy across the group file as well. And therefore the user ID and the group IDs that I created earlier are all just going to be pulled across there. And then final thing that I need to do is just set the user. So to do that, I'm just going to set the user to web, and it's going to be part of the web group. I'm just going to save that, and then when I run that command application, it's going to be running within the context of user. So if I come back into my terminal, let's clear all of this, and we're just going to do a docker build again. It'll take a few seconds to do that. Okay, so my Docker image is now created, and then if I just do a docker run, my application's back up and running, and then if I do a curl, you can see whoosh Freddy, my application is working, but now I'm running, rather than as a root user, I'm now running as a least privileged user. Okay, so that is it. This is our application. We've solved 3 problems in this. If you remember, we've brought our image size from 2.1 gig to 27 meg. We've solved the problem of our build times, and we've reduced it down from 2 minutes to about 8 seconds. And and both of these is because we've introduced multi-stage builds. And of course, for the build timeline, what we've done is use the cargo chef tool, which allows us to build our dependencies as one of those stages, and then just copy the dependencies into our application. And then finally, what we've done is we've made our image secure more secure by using a least privileged user rather than root to run our application. So that is our multi-stage production Rust Docker image. Anyway, I hope this video has been useful, and then in the next video what I'm going to do is we're going to build off of this knowledge, and then we're going to actually take our images and then run them on Google Cloud Run and use Google Cloud Builder to build our images. Anyway, hope this has been useful, and I'll catch you on the next video.